Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about frequency modulation and amplitude modulation from Cambridge A2 Physics. In this video, our main focus will be on frequency modulation. I'll explain you how to find amplitude, minimum frequency, maximum frequency, and the rate at which frequency of FM wave changes with the help of past paper questions. First of all, let's try to understand what is amplitude modulation. For amplitude modulation, the first thing we need to understand is that the amplitude of the carrier wave is made to vary in synchrony with the displacement of the information signal. What exactly it means? It simply means that the amplitude of this modulated wave, it is depending on information signal and it is depending on amplitude of carrier wave. Let's say the amplitude of this carrier wave is AC, amplitude of signal is AS, and amplitude of this modulated wave is AM. Now simply you can see from here, when the amplitude of signal is positive, the amplitude of this modulated wave, this is greater than amplitude of carrier wave. So it simply means when the amplitude of signal is positive and increasing, amplitude of carrier wave will be increasing, and that will be the amplitude of amplitude modulated wave. And when amplitude of signal is negative, so amplitude of carrier wave will decrease and amplitude of modulated wave also decreases. Let me write down in a simple way so you can understand better. So let's say here we have amplitude of modulated wave and amplitude of modulated wave. It is depending on amplitude of carrier wave and it is depending on amplitude of signal. When amplitude of signal is increasing and it is positive, amplitude of modulated wave will increase. And when amplitude of signal is decreasing and it is negative, amplitude of modulated wave will decrease. If we look at the second point is simply telling us that the frequency of the carrier wave does not vary. It simply means that the frequency of modulated wave is the same as frequency of carrier wave. So we can simply write down the frequency of modulated wave is equal to frequency of carrier wave. Next point is simply telling us that the variation in the amplitude of the carrier wave is depending on the displacement of the information signal. It simply means that when the displacement of information signal, this is bigger, the change in the amplitude of carrier wave will be bigger. And when displacement of information signal is small, then the change in the amplitude of carrier wave will be small. Or we can simply understand this one from amplitude modulated wave. When the displacement, if this displacement is bigger, the change will be bigger, mean the amplitude of this one will be bigger. If amplitude, or we can say the displacement of information signal, when this is small, the change in the amplitude of carrier wave will be small, and we will also see the small change in the amplitude of modulated wave. So simply we can write down that the change in amplitude of modulated wave, this one is depending on displacement of information signal. Depending on displacement of information signal is depending on AS. So it means this is amplitude of information signal and here is amplitude of modulated wave. Next point is telling us the rate at which the carrier wave amplitude varies is equal to the frequency of the information signal. Rate simply means that the number of times the amplitude of modulated wave increase, decrease, and then increase is depending on the frequency of the signal. Or we can simply say that rate of change of amplitude of modulated wave, it is equal to frequency of signal. Now we have good understanding of amplitude modulation. If your concept about amplitude modulations are very clear, then frequency modulation is very simple to understand. Frequency modulation, when we talk about frequency modulation, it simply means that in this case frequency of carrier wave changes. So this is the first point you need to understand. So when we were talking about amplitude modulation, we said amplitude of carrier wave changes depending on displacement of information signal. But for frequency modulation, frequency of carrier wave is changing based on amplitude of information signal. Now the first point simply telling us frequency of the carrier wave is made to vary in synchrony with the displacement of the information signal. So in this case we can see here, when this displacement, this is positive, the frequency is increasing. When this displacement is negative, frequency is decreasing. Now next one, second point is simply telling us the amplitude of carrier wave does not change. So this is frequency modulation. So in this case frequency of carrier wave change, but amplitude does not change. So we can simply say that in this case amplitude of modulated wave is the same as amplitude of carrier wave. So you can see here, this is our carrier wave, it has amplitude AC, and our frequency modulated wave has amplitude AM, and these two are equal. Now let's move on to next point now. Third point is simply telling us the change in the frequency of the carrier wave is depending on the displacement of the information signal. So it's simply telling us is that when the displacement of the signal, this is positive, frequency of modulated wave, this is increasing. And when displacement, as you can see here, when displacement of this signal, this is negative, frequency of modulated wave is decreasing. Frequency of modulated wave is decreasing. So this is what this point is telling us. Last point is simply telling us the rate at which the carrier wave frequency is made to vary is depending on the instantaneous frequency of the signal. So it simply means that number of times frequency of carrier wave, or we can say frequency of modulated wave, increase, decrease, and increase again. This is depending on frequency of the signal. If signal has more than one frequencies, it will depend on instantaneous frequency of the signal. So this is simply, it means by rate. We can write down rate of change of frequency, rate of change of frequency, modulated wave frequency is equal to frequency of signal. Let's try to answer this question now, and for this question it is given to us that a carrier wave is frequency modulated. So we need to describe what is meant by frequency modulation. Frequency modulation simply means that the frequency of carrier wave will change with displacement of information signal. We have discussed a lot about this one. Let me show you how to write answer for this one so you can get 2 marks. This is how you can write your answer for this question. So if you write this one, you will get 2 marks. Now let's move on to next one now. If we read this question carefully, it is given to us that carrier carrier wave has frequency, and this is frequency of carrier wave is given to us, and amplitude of carrier wave is also given to us, that is here, and carrier wave is modulated by signal and frequency of the signal is given, so we can say this is frequency of signal. And amplitude of signal is also given. We can say this is amplitude of signal. Frequency deviation is given to us of the carrier wave, and this is 20 kilohertz per volt. It simply means that the frequency of carrier wave will change by 20 kilohertz when amplitude of signal changes by 1 volt. So this is frequency deviation. Mean how much frequency of carrier wave will change depending on amplitude of the signal. So if amplitude of signal changes by 1 volt, frequency of carrier wave, this will change by 20 kilohertz. If amplitude is positive, frequency of carrier wave will increase by 20 kilohertz per 1 volt. And if amplitude is negative, frequency will decrease by 20 kilohertz per 1 volt. Now, first part is simply asking us determine for the frequency modulated carrier wave, what is the amplitude of frequency modulated carrier wave. So we understand in frequency modulation, amplitude of carrier wave does not change. Only frequency of modulated wave change. So we will simply say amplitude of frequency modulated wave is the same as amplitude of carrier wave, and amplitude of carrier wave is already given here, so this is simply equal to 5.0 volts, and that is our answer. Second part is simply asking us, we need to calculate the minimum frequency of the frequency modulated wave. Minimum frequency we can simply calculate. If we have frequency of carrier wave, we just simply need to subtract frequency deviation. So I will just write down here, this is frequency deviation, and this one we need to multiply with amplitude of signal. So if we plug in values, we can simply find out, because frequency of carrier wave is given, that was 750 kilohertz, and frequency deviation was given, that was 20 kilohertz per volt, and amplitude of signal is also given, that is 1.5 volts. Now if we simply solve this one, our final answer will be 720 kilohertz, and this is the minimum frequency of frequency modulated wave. So our final answer is 720 kilohertz. Now next part is asking us maximum frequency, so simply we need to add. So again we can write down maximum frequency, that will be equal to frequency of carrier wave plus frequency deviation. So here is frequency deviation, and we need to multiply this with amplitude of signal. So just we need to plug in values now. You can see this is 750 kilohertz plus frequency deviation we have, that is 20 kilohertz per volt, and we simply need to multiply with amplitude of signal. Amplitude of signal was 1.5, that is given to us 1.5 volts, and in this case our final answer, that will be 780 kilohertz. So this is our final answer. Last part is simply asking us the number of times per second the frequency of frequency modulated wave changes from its minimum value to maximum value and then back to minimum value per second. You can see here, if you look at this frequency modulated wave, you can see frequency here is maximum, then frequency becomes minimum, and then here frequency is maximum again. And this is depending on frequency of the signal. So this is depending on frequency of signal. If you look at this one, when amplitude is positive, frequency will be maximum, and when amplitude is negative, frequency will be minimum. You can compare here, and frequency will be minimum. And then again, when amplitude is positive, frequency will be maximum. So it simply means that the rate of change of frequency, it simply depends on frequency of signal, and frequency of signal is already given to us, that is 7.5 kilohertz. So our final answer is 7500 per second.